My duty in this session was to make an introduction to algal technologies. Luckily, I have, after me, Gabriela Sien, I have Vito speaking. So I will just do something very general and try to emphasize, try to speak about challenges of algal technology, which somehow we have seen that there's a kind of when somebody enters the field, it's very frequently like ignorance. In the beginning you don't know anything about algae, then you learn slowly, you see all the activities going on, the kind of enthusiasm, hype, everything is possible. And then you start to see what are the real problems. And this stage I would like to talk about. And in addition to making general introduction to what are we working with algae, to other people who are not very fluent in this area. So, of course, what are algae? Photosynthetic organisms, aquatic, simple non-plants. We distinguish microalgae, macroalgae, and cyanobacteria, let's say taxonomically, although for the purposes of algal technology, we don't distinguish cyanobacteria from microalgae, but we do distinguish macroalgae from the rest of the, well, sometimes, or most of the times, from the rest of the cultivated species. And of course, macroalgae can be also called seaweeds. Species in this target group vary significantly in size. So we are talking about very tiny unicellular species up to 60-meter long kelp species. So we are very diversified in this area. There is a, you still hear me? There is very nice white paper done by European Algae Biomass Association, What are algae? So I will not go into further detail here, but the nice picture presented here is from that cover page of that report. What I would like to say, it's we are spanning species from eukaryotic sites and prokaryotic sites, so bacteria. Then we do include sometimes also some species that perhaps belong to fungi into our subjects, but let's stick to very general. What behaves and acts as algae are algae. So what we frequently see is a pitch. Why would we grow algae? I mean, after the ignorance, we frequently see the pitch. Why would we go algae? What are the advantages? And of course, they include those topics. I omitted simple non-truths, but all those claims that are here are partially true. So algae are fast growers. They can grow 3 to 15 times, let's say perhaps 3 times. We have better yields. There are literature articles also claiming 150 tons per hectare. I would say maybe we can do 30 tons per hectare. We have continuous harvesting. That is very important. So instead of 1 harvest per year or 2 harvests per year, we are harvesting daily. We frequently use fertilizers much more efficiently. We don't have losses to underwater, groundwater, or anywhere else. We can recycle the growth media. We use degraded, non-arable land if we have such land. We don't present pollution, no pesticides, no losses of fertilizers. We are not competing with food production. We are fixating CO2. And this topic is now very important. I will not go into deep detail here, but that is a controversial topic. I mean, we are fixating CO2 as any biomass does, which means that it's not typically not sequestration. We do it as efficiently as any biomass, but there might be still some possibilities that where we can present algae as good for climate in this time where we are looking for options how to remove CO2 from the atmosphere. And of course, we can use all the organisms, no waste, no lignins, and we frequently say we can grow algae on waste streams. So have nutrients that are essentially free or even have negative costs. So most of those, you can find many of those videos that are, promoting. I would say yes, all of them are partially true. I wouldn't. I mean, we can still have this statement: algae will save the world, although not so easy. And I'm sometimes quoting that algae have all God's attributes: omnipotent, omnipresent, omniscient. Most of the science of photosynthesis has been developed from algal studies and so on. So yes, all this is true, but we come back how true they are. Of course, why would we grow algae for algal products? And this is the list of potential products, products that are all being done from algae. What I would like to say, a few words. Algae is a very rich protein, very protein-rich biomass. So very, let's say, fashionable or environmentally sound way to produce proteins, because animal proteins are environmentally very costly. So in all those activities where we are talking about meat replacement, algae come close into the consideration. Algae are primary source of omega-3 fatty acids in the ocean. They come from algae to krill to all higher level organisms to fish. So when we are talking about having omega-3 fatty acids from fish, they essentially come from planktonic organisms. And this topic, oxygen, here is just there because very frequently when we are talking about using algae in bioremediation, we actually use algae for producing oxygen. So in the microbial communities that do the actual water treatment or bioremediation, we have algae as oxygen producers and bacteria as actually consumers or converters of organic matter in the wastewater to CO2. So because in most of those, in many of those applications, we just using part of algal biomass, biorefinery has become an important, very fashionable concept. So how to use all of the biomass, not just in algae, but in other species. So biorefinery is now, you will hear more about this in these sessions, but the idea is how to use the whole biomass for different purposes. Just a note, biofuels have been the reason why algae became popular like 10, 15 years ago. They have lost its appeal for some time because it's very hard to economically produce biofuels. But recent developments in the United States and in Europe also restart the area of biofuels. So maybe biofuels could be also a potential topic for algae. algae installations. Now we are talking about, we were talking about very general about algae and use, and whenever you see a scientific paper, they make an introduction. Yes, algae can be used for everything, and their potential is immense. Now we are talking about technological issues. So yes, algae at lab scales are doing miracles. They have super fast growth rate. They produce perfectly. They are very clean culture and so on. As I said, most of the knowledge of photosynthesis, well, a significant part of the knowledge of photosynthesis has been developed on algae in lab scale work and so on. So a lot of work is now done on physiology, genetic, metabolomic research. We are able to in recent times, we are able to genetically modify algae to perform certain, to produce certain products and so on. But you know, lab scale is something completely different than the pilot scale or the large production scale. And this is, you have to try it to know. Kind of problems that you emerge in
Robert, if you hear us, we lost you. You're back.
Sorry.
You have 3 more minutes, by the way.
You hear me? Yeah, okay.
Yes.
So, as I said, some of those topics are well known. I would like to stay on this slide because in those 3 minutes, and this is not many pictures. I will just tell you the stories, what we see when we are moving from lab to large scale and very large scale. So the things that the challenges that we have to solve in making algal cultivation installations. So first of all, we have to, although there are installations with artificial light, most of the installations are done with using natural light, and here we have problems of penetration, how deep into our growth media light comes, and we also have problems of photoinhibition. If there is too much light, we have slower growth. We are always considering area. There are ideas or perceptions that placing algal systems vertically improves aerial efficiency. It's not true. The area of shadow is the one that counts. So we have vertical, horizontal biofilm and pond installations, but still we are not able to do any magic here. The light available determines the production. Of course, one of the very important things is thermal management of the systems. In these shallow ponds or small volume bioreactors, we always fight the overheating or perhaps cooling of the systems. And in those systems, we don't have thermal capacity that we would be buffering the temperatures. So this is always an issue that we are solving. We claim we are working in closed systems. We are working with pure, let's say, artificial nutrients. It's very hard. I mean, here this is aquatic organisms, and anything in our nutrient solutions attaches or comes into our algae. So, as an example, it's very hard to get sodium bicarbonate without arsenic. Very interesting contamination. We always have to introduce inorganic carbon or CO2, questions of purity, but also how to introduce in significant quantities in our ponds. Very surprising problem in large scale is oxygen toxicity. We have to remove oxygen from our media as it will reduce the growth, and removing oxygen from the ponds is not always as simple as it seems. I mean, at the rate it is produced by photosynthesis. Then we, in open or semi-open systems, we always fight birds, rodents, insects, lizards, amphibia, and smaller grazers, amoeboids, rotiferae, ciliates, zoosporic parasites. They are parasites that are able to kill our ponds in a matter of days, or let's say few days. So these are practical problems that we are facing. Then, of course, the very unexpected things. In any large-scale pond or photobioreactor, you have sediments, you have dirt collecting, you have biofilms, and the biology in those places is different from what you want. So it's not impossible that you see anaerobic bacteria as the contaminants in your culture. The system is over-oxygenated, but there are some puddles or some biofilms on the edge, or some piles of sand at the bottom of your pond that you will not see, and you will encounter those problems always. So my rule of cultivation of algae is always cleanliness and good conditions to grow algae. And of course, separation. You don't want all of your culture to go wrong if something happens. Then just mention a few things, and then I will leave the essential or fundamental or crucial problem in algal cultivation is always harvesting. It's illustrated with the ratio for 1 kilogram of algal biomass at typical density, where your light penetrates just a tiny bit into your pond. You have to shuffle a ton of water, which makes all harvesting always a marginally effective regarding energy. So we have developed, and we are harvesting small fragile cells that don't differ a lot in buoyancy. They don't sediment usually naturally. And the harvesting is always a magic combination of sedimentation, flotation, combined with flocculating agents, or perhaps electrocoagulation, filtering, and centrifuge. So it turns out that for different species, you need to find a combination of those techniques that works economically and efficiently. Then talking about the watering, of course, media is non-edible typically. So you don't, if you're producing food or feed, so you want to remove as much media as possible before drying the algae. And typically, in the species that we frequently grow, some of them the media is protecting the species. So removing the media makes them exposed to various influences of natural environment. So we have to do this fast, efficient, and we have different approaches, from spray drying, freezing, no drying at all, and the secret here is doing it fast and clean.
Robert, please.
What the summary of this? We have wildly variable quality of large-scale produced algae, with a lot or small amounts of foreign biomass. We have heavy metals. We have polyaromatic hydrocarbons, we have bacterial contamination, we have cyanotoxins. More or less depends on the quality. The essential result is that high cost is still algal biomass. It can be produced at cost that is, let's say, at least 5 times more expensive than commodity crops. But ranges are wide. Commodity crops are subsidized, algae are not. We have uncontrolled competition from, Far East, lower quality algae coming to the market at, let's say, undefined quality.
Robert, sorry to interrupt you, but I see that Maya is suffering from your time management.
Yeah. So, and that's my last slide. Anyway, that's what I wanted to say.
Vitor, thank you.
Vitor, you think Maya is not able to? Yeah, okay, sure. That's my last thing I wanted to say. The rest will be told by Gabriel and Vita.
Thank you. Maya, go ahead, please.
Thank you, Vito. You are very nice. So thank you, Robert. And you will see that if you have any issue, Robert is very knowledgeable. So he is also a part of the BioRural network, and you can pose him questions.